Hello and welcome to today's lecture about chemical formulas. To write chemical formulas, you need to understand oxidation states in the periodic table. If we look at the first A group in the periodic table, all elements in that group have oxidation state of +1. Same goes for 2A and 3A. They have oxidation states of +2 and +3 only. From 4A to 7A, there's a few positive oxidation states and always one negative oxidation state. For 4A, it's +4, +2, and -4. For 5A, it's +5, +3, and -3. 6A have +6, +4, and -2 oxidation states. And lastly, 7A have a lot of positive oxidation states, +7, +5, +3, and +1. A negative oxidation state is always -1. In this lecture, we won't be talking about B group elements' oxidation states, because they are called chaotic elements and there are almost no similarities of oxidation states in the same group as we saw with the A group elements. Now let's talk about the A group exceptions. First is hydrogen. If hydrogen is form a compound with a nonmetal, its charge are always +1, and with metals, it's always -1. For example, in hydrogen chloride, hydrogen is +1 and chloride -1. But in sodium hydride, sodium is +1 and hydrogen is -1. Next exception is in the 6A group and it's oxygen. In every compound, oxygen is always -2. For example, in compound named sodium oxide, sodium oxidation state is +1 and oxygen is -2. Last exception is fluorine in a 7A group and its oxidation state is always -1. In sodium fluoride, sodium is +1 and fluorine -1. Now, when we know oxidation states of different elements, we can make some chemical formulas. For example, if we have sodium and sulfur in the compound, sodium charge must be 1 plus because it's in a first A group and sulfur charge is 2 minus. Now all we need to do is swap charges with subscripts. This is called crisscross method. So all we do is writing one subscript towards the right and another towards the left, and we get Na2S formula. We never write one in chemistry, and because of that, there's no subscript near the sulfur. Let's do another one. This time we have magnesium with charge 2 plus, because it's in second A group, and nitrogen with the charge of 3 minus. Now remember that in every compound there must be one cation and one anion. No compound exists where we only have one species of ions. Once again, we swap charges with subscripts and we get formula Mg3N2. Next, let's say we have aluminium and chlorine. Aluminium charge is 3 plus and chlorine is -1 because it's in a 7A group. Once again, we're doing crisscross method and we get AlCl3 formula. Remember that we don't need to write one in chemistry. Now what to do if ions have same charges? Let's look at sodium chloride. Sodium have charge of 1 plus and chloride of 1 minus. If we do crisscrossing, we should get just NaCl. However, if charges are not plus and minus, but for example 2 plus and 2 minus, we have different situation. In this case, we have calcium 2 plus ion and sulfur 2 minus ion. If there is a possibility to divide oxidation states from the same number, we must always divide it. So we get calcium plus and sulfur minus. And now we can swap charges with subscripts. The answer to this problem is CaS with no subscripts. What about aluminium 3 plus and nitrogen 3 minus? Well, we can divide both numbers from 3 and we get ALN as an answer. Okay, let's do a few more of these. Let's say we have C plus 4 and O2 minus. Now we can divide both of those numbers by 2 and get C2 plus and O minus. All that's left is to do crisscross and we get our formula, which is CO2. In this example, we have sulfur with 6 plus charge and oxygen with 2 minus. Once again, we divide both of those numbers from 2 and we get S3 plus and O minus. Last step, once again, is to swap charges with subscripts and we get CO3 formula. Last example will be with sulfur 4 plus and oxygen 2 minus. We divide both numbers by 2 and get CO2. Keep in mind that you don't need to show how you divide charges. You can do it in your head and then write the answer down. Okay, let me change page really quickly. And now I showed you how to work with monatomic ions. But how about polyatomic ions? Let's look at a few examples. Let's say we have calcium 2 plus and polyatomic ion called nitrate, and its oxidation state is minus. Once again, we swap charges with subscripts. 2 goes towards the nitrate ion, and 1 goes towards the calcium ion. Now what we need to remember is to enclose polyatomic ions in the parentheses, and in this situation we get calcium nitrate times 2. On to the next example. In this problem we have potassium plus ion and polyatomic ion phosphate with 3 minus charge. Like in all previous examples, we do crisscross method and we get K3PO4. Now we don't need to enclose PO4 ion because we don't write one in chemistry, as I mentioned before. In this example, we have alumina 3 plus ion and a sulfate 2 minus ion. After changing charges with the subscripts, we get aluminum 2 sulfate times 3. And last example in today's lecture is magnesium 2 plus and sulfate 2 minus. And once again, if you can divide charges, you must always do so. The answer we get is MgSO3. And that concludes today's lesson about making chemical formulas. However, this video isn't over just yet because I prepared 10 problems with answers that you can try on your own. Pause the video after the problems are shown and after a few seconds I will show the answers. Please like this video and don't forget to subscribe for more chemistry content. See you soon. Here is 10 problems for you guys, and now let's go to the answers.